Dan. I'm Yasith. I'm a software engineer from Google. I work in the CameraX team, and so today we are going to be talking about building a Compose-idiomatic CameraX Viewfinder, a deep dive. So it's quite a long title, so I'll break this down later. So first of all, what is a viewfinder? So a viewfinder is something that displays the camera feed. We have to do a few things with the viewfinder. So first of all, the primary goal is to display what the camera is seeing, but we also have to ensure that we are doing proper cropping and we have a proper aspect ratio. And then we also want to support some common use cases such as tap to focus. For that, we had to do some coordinate mapping. And building this is a slightly complicated in a Compose world, just because there are so many other things attached to this view, such as the camera, which is an external physical system. So let's get into it. So the first thing we mentioned was we want to display the camera feed. This is actually pretty straightforward because we are using CameraX. So CameraX will take frames from the camera and will draw into a surface inside of our viewfinder. And then second, we mentioned that we want to ensure proper cropping and aspect ratio. So when drawing frames onto the viewfinder surface, we have to ensure that we are cropping so the right parts are visible. You really want to make sure your preview contains what you're capturing, because most of the time with a camera preview, we are also capturing images. And if you show in your preview more than what you capture, then you might be missing something, and that's not great. But also, if you capture more than what's shown in your preview, that can also be pretty bad. So let's see how we can handle this. So this is my dog Felix. Let's say I'm going to take a photo of him. So this is him in the real world, and we have our screen where we want to show show the frames that we get from the camera of Felix onto the phone. And this happens by the real world being projected onto the camera sensor, as shown here. But if you look closely, you'll see that the sensor has the x-axis vertically and the y-axis horizontally. Why is this? Because before phone cameras, they were just regular cameras, and they use sensors. They would read pixels from left to right, top to bottom. The x-axis is horizontal, like we're used to, and the y-axis is vertical. So when we were building cameras for the phones, we just took these sensors that's just available to us, and we put it on the phone. And we also wanted to maximize the field of view according to the phone's natural orientation and the display. So we had to turn it around, and we ended up with sensors with the x-axis going vertically and the y-axis going horizontally, which means the real world gets projected onto the sensor, but what the sensor sees is something like this. So the image is rotated 90 degrees. This can vary according to the camera sensor, but this is a typical example. So the first thing we have to do with the viewfinder is we have to rotate it so we get back to the natural orientation. So that's pretty easy to do. And then we have to scale the frames we get to fit into our viewfinder size. And then we have to translate it to fit it appropriately into the viewfinder's frame. Then finally, we have to make sure it's cropped. So it's properly displayed. And then we had to do something called coordinate mapping, we expect the viewfinder to be able to map between coordinate systems, but what does this mean? Sometimes, you're probably used to this, you look through your camera and the object is blurred. And what you usually do is you tap somewhere and the camera brings the image back into focus. So this requires some work. We call this coordinate mapping. The touch events, they happen in the Compose coordinate space, and the focusing events in the camera, they happen in the sensor coordinate space. So yeah, so for example, if you're tapping on Felix's nose, so in the Compose coordinate space, we might be in XC and YC coordinate, but converted into the camera sensor, this is going to be XS and YS. So, and basically, our viewfinder needs to help with use cases like this. All right, and finally, so we are building a viewfinder, but we also want it to be Compose-idiomatic. Why? Why do we want it to be Compose-idiomatic? We want the best experience for the users of this composable. It will be familiar to use, like other composables, and they should be able to use existing Compose utilities, such as the Compose modifier, the gesture system that we have available in Compose, and it also fits nicely with modern Android architecture. So how do we do this? How do we make something Compose-idiomatic? So we had to keep much of the state out as possible, and then as with the composables that we see in the foundation framework, we want to take a layered and additive approach. And we had to make it compatible with other Compose utilities, such as the modifier and the gesture system, like I mentioned earlier. And most importantly, we want to make it feel familiar to other composables that developers are used to. Let's also talk a little bit about state ownership. So you can see a traditional view, and in the traditional view, you usually have the state inside of the view, and you have events that go out from that view. But in composables, we prefer to bring the state from outside into the composable, and the events are the same. They go outside from the composable. And views, they have like variables, getters, and setters. Composables use functions and state as arguments. So this is one of the main differences. So we talked about building a Compose-idiomatic viewfinder, but we're also building this with CameraX. So what is CameraX? So CameraX is a Jetpack library. It's built to make camera app development easier. And so let's see how CameraX works when drawing preview frames onto a surface. So CameraX has an interface and a concept. It's called the surface provider. You can implement this interface to tell CameraX that you will be providing for a surface for these camera frames to go into. So let's see what the surface provider looks like. It's a function interface. It has one function. The whole purpose is to request a surface, and we request a surface with the surface request object. So let's look at the surface request. The surface request is pretty simple also. It has a resolution, and it has something called the transformation info. These are like these are the transformations we need to apply to the frames that we get from the camera. So it will be the same as the images that are being captured. We'll talk more about the transformation info later. But let's look at an overview of how the camera gets connected onto a surface. So first of all, CameraX gets the surface provider, set surface provider function called from the viewfinder, and then CameraX sends a surface request into the viewfinder saying, hey, give me a surface with these criteria. And then the viewfinder goes ahead, creates a surface, and sends the surface back into the camera so the camera can start drawing frames. So we do have something that does all of these things now. It's called Preview View. It does all of this and more, but let's see what it is. So it's a view-based library. It keeps a lot of internal state, and we tried wrapping this with Android View to see how users like it and to see how we like it, but it didn't feel great to use with Compose. So this is what Preview looks like. So this is just a few of the public methods that Preview has. So all of these getters, and there's also some setters. I didn't have space in the slide to fit everything, but you can see this is a lot of internal state, lots of methods. And if you want to wrap this with Android View, this is what it kind of looks like. So we have to keep a connection between the Preview View and our view model in order to call the Preview View's functions. And we do this through what we call the preview state. So this is what the API for a viewfinder wrapped with an Android View kind of looked like when we implemented this. And I know other people also implemented something similar. So we create a preview state and we pass that on to the viewfinder. So the preview state, it kind of looks like this. It holds a reference to the preview view object, and it kind of acts as a delegate to the functions inside the preview view. So anyways, this didn't feel too good to use. So this is, in summary, traditional views like preview view, they are stateful. Composables are better suited to be stateless. They feel so much better to use when they're stateless. And having to manage the states in preview feels bad when integrating with Compose and other modern Android architecture best practices. All right, so let's try and do this from scratch. Let's try to create a native composable. And for the surfaces, we're going to be using the Android external surface and the Android embedded external surface. So for those who are not familiar, Android external surface is pretty much the surface view, and the Android embedded external surface is the texture view. When we actually started building this, these were not available, so we built our own. But the Compose team has built a much better composables, so we switched over to these. All right, so so we're building the viewfinder from scratch with Compose. And if you remember, the first thing to do is we want to display the camera feed. So like I mentioned earlier, we need the surface provider, and the surface provider gets tightly coupled into the camera. Like I mentioned earlier, so we actually want our users to implement the surface provider. It's a functional interface, which means it's only like one line, and it really helps to decouple our camera logic from our views. So as a reminder, this is what the surface provider interface looks like, and it's actually really easy to implement this. So we can do it like this. We can set the surface provider with the functional interface, and any surface requests we get, we can put it into a state flow, and now we have a flow of surface requests that we can get from the camera. Next up, we have surface requests coming in. We have to send it into the viewfinder. That's actually really easy with Compose. We create a composable and we just pass it on. We just pass on the surface request into the viewfinder. And we'll talk about the implementation mode later. It's basically what type of a surface we're using, either the surface view or the texture view. So now we have a surface request. Now we have to create a surface. This is the fun part. So let's review the surface request again. We have the resolution. That's the resolution of the frames we're getting from the camera sensor, and then we have the transformation info. basically, I mentioned earlier that this is how we want our camera frames to be transformed. So the transformation info contains just these few things. So first of all, the source rotation. So if the camera sensor is rotated, we want to know that, so we have to rotate back into the natural orientation. And then we have the mirrored horizontally and vertically. Most of the time, this is just mirrored horizontally. For example, in the selfie camera, you want the image we get to be mirrored. And then we have a crop rectangle, basically telling us this is, if we are capturing images, this is what we are going to capture. So we have to make sure we also show that crop rectangle in the preview. Yeah, so in order to do this, let's make a child composable. And yeah, so this, we call this a transformed surface. So basically for this one, we just send the resolution and the transformation info we got from the surface request along with the implementation mode that the users requested. And yeah, so the first objective is for us to create a surface, and depending on the implementation mode, we will either create an Android external surface or an Android embedded external surface. So you'll notice that we are passing on a modifier into these surfaces. So let's see what this modifier is about. All right, so here we create the modifier that we are going to pass on to the surface. So let's go more into detail. So here we are doing most of the work in Compose's layout phase. If you're familiar with Compose, Compose has 3 phases. One is the composition phase, where it creates the tree of the Compose nodes, and then the layout phase determines how to place things. So yeah, so we can measure the placeable that we want to place inside the composer, and in this case it's our surface, and we want to measure to fit a surface for the given resolution and height that we get from the camera. Then we also have to do some offsets, just because if in Compose, by default, a child is centered in the parent, and if there's any overflow, we want to be able to do our math with the child composable and the parent lined up at the origin. So so we calculate some offsets, and then we lay out our placeable inside with place with layer, and inside the place with layer we can do some more calculations to get everything to line up. So in this talk I won't go too much into the matrices and how we calculate our transformations, but we get a matrix for the transformations we want to do to the frames that are getting drawn onto our surface. And then we calculate a rectangle that's basically the size of the images that we get from the camera, and then we apply our matrix onto that rectangle to make this will give us the scaling and transformations, the scaling and the translations that we want to apply inside of Compose. So inside of Compose, so the scale is pretty straightforward. We calculated our rectangle, and we have the size of the frames we are getting, so we can just divide one by the other in order to figure out how much we want to scale. And the translation is also pretty simple, because we previously laid out everything at the origin. Yeah, so now we should have an appropriately scaled and positioned surface that we can draw frames onto. Yeah, so what's left to do is we have to send the surface over to the camera, and we can start drawing frames. And when we created our external surfaces, we passed the onInit from the transform surface into the Android external surface. So that means when the Android external surface starts up, we will get a callback and we will get a surface when the Android external surface creates its backing surface. So we can just send this one back onto the camera, and the camera will start drawing its frames. Yeah, so this is that part. I didn't go into this slide. Okay, so yeah, so finally our camera is connected to our surface, and we can start drawing the frames, and the cropping and transformations should be there. So in summary, this is an overview of what our Compose will looks like right now. So we start this, we have a layered system, and that makes up the CameraX Viewfinder. So starting from the inside, we have an Android external surface or an Android embedded external surface. We wrap this with the transformed surface, ensuring the cropping, and then we do have another composer that we didn't talk about called the Viewfinder. This is for some compatibility reasons. We also wanted this to work with Camera 2, and then we wrap everything again with CameraX Viewfinder. And the key here is we have a layered system, and each layer adds more complexity gradually. Anyways, yeah, but we are not done yet. We have to do the coordinate mapping. Like I mentioned earlier, if we tap somewhere in the Compose coordinate space, it has to go somewhere else in the sensor coordinate space. So in order to do this, we add one more argument, a coordinate transformer, to transform our coordinates. Well, what's that? So we define our coordinate transform here. It mainly has one thing, a matrix to use for the coordinate transformation, and we also have an extension function on offset. So for those who are not familiar with Compose's point input system, they use offsets to give coordinates for taps or gestures. Yeah, and then we also have a mutable coordinate transformer, which just makes the transform matrix mutable. And to go back, why the extension function on offset is important is by keeping this flexible and offering an additive on top of the offset, we can keep using the existing Compose gesture system like you would normally when we are using our viewfinder. So yeah, so this is how it would look like when we use this coordinate transformer with a pointer input. So we set up the pointer input in the modifier, we detect tap gestures, and from there we get an offset, and then with the coordinate transformer, we can just call it.transform to get our tap with the proper offset. All right, so this is what the final API looks like. So we have a surface request. This is the only required argument, and it helps us connect the underlying surface with the camera. And then we have the modifier, just like any other composable. We respect the modifier, and that means building with this CameraX Viewfinder should be easy for you. And then finally, we have the implementation mode. This is to determine what kind of a surface we want to use as the backing, a texture view or a surface view. And then we have the coordinate transformer that we just talked about. Yeah, so the Composable Viewfinder, it's stateless. It feels very familiar when using Compose, and people who used it liked it so far, so that's good. And let's take a look at how this would look like in a modern Compose app when we have everything separated in different modules. So we have our CameraX module, our view model, and then our viewfinder composable. So the view model can set the surface provider inside of the camera preview and get a surface request in return, which it can pass on to the CameraX Viewfinder composable. And the CameraX Viewfinder composable provides the surface back into the CameraX's preview, and then start getting frames that we can start drawing onto the surface. So yeah, so that's it. And let's see the usage. When we have a surface request, using the CameraX Viewfinder is just one line. Yeah, so it's pretty nice to use, but in a more complicated example, it still feels very similar to any other Compose code. Yeah, so here we are creating a coordinate transformer, a mutable coordinate transformer, and then we set up our CameraX Viewfinder composable. We send in a surface request, we set the implementation mode. Here we are using the surface view as the backing. And yeah, so inside the modifier, we are filling up to the max size, and we are also doing some touch gestures. And finally, we pass in the coordinate transformer into the composable. Yeah, so while building this library, something we did was we wanted to build our own sample camera app while strictly following modern Android architecture guidelines. And I think it's well architected. So if you are interested in camera or Compose, please check it out. You can scan the QR code, or you can go to Google/JCA. And we are continuing to add new things to this camera app using new features of CameraX, and maybe potentially other media composables too. Yeah, also, we just released the CameraX Viewfinder in alpha last week. If you're looking to using it, please come talk to me. I'd love to chat. We also have a version that's compatible with Camera 2. If you're still using Camera 2, that's also okay. You can use it in Compose. So what did we learn from building this? So native composables, they feel so much better to use compared to wrappers. I mean, I think that pretty much goes without saying. We've had this feedback from developers a lot, that sometimes when you try to use existing views, it just makes the whole architecture like a mess in your app. And then we built our composable in layers of increasing complexity. So we went back and forth with the Compose team when building this, and this is something they really emphasize, taking an additive approach. So in addition to building in layers, it's also nicer to be flexible with things like the coordinate transformer. So as many things as you can pull out, it's nicer when it comes to Compose. And yeah, so also building an app alongside with this library really helped us identify the pain points. And it helped us so much that we are continuing to build our sample app for everything else. Yeah, thank you so much for coming to my talk. And if you have questions, I think we do have some time. Also feel free to just grab me afterwards. I'd love to chat.